Today's notes are on Newton's second law of motion. An object accelerates because the force acts upon it. The larger the force, the larger the acceleration. The larger the mass, the larger the force needed to accelerate it. Newton's second law is often written as the equation, force equals mass times acceleration. What this means is if we have a bowling ball and a tennis ball, and we give both the same amount of force, either a push or a pull, the bowling ball would have less acceleration because it has more mass. Let's look at a few examples. In this picture, we're comparing the amount of force that this young man is applying to the same cart. In the first picture, he's applying just a little bit of force, and the acceleration is small. In the second picture, he's applying more force to the same mass, so the acceleration is greater. A similar example in this picture, the young man is applying a small amount of force. The older man is applying a larger force, so the larger force receives more acceleration in the cart. In this picture, we're comparing the different masses of the cart. So in the first picture, since the cart is empty, when the force is applied, the cart has a greater acceleration. Once we add more mass, if the force stays the same, the acceleration is less. If he pushes the cart with more force, then the acceleration will increase again. In today's activity for Newton's second law, you're going to get 3 different sized paper grasshoppers. So 3 different grasshoppers with different masses. Your objective is to apply the same amount of force to each grasshopper and observe the differences in the amount of acceleration or how high the grasshoppers jumped based on their different masses. Now let's move on to talk about calculating motion. The formula that we're going to use for speed goes into a triangle similar to the one we used for calculating density. Speed equals distance divided by time. Just like the density triangle, you can rearrange the formula to solve for different parts. So speed equals distance divided by time. Distance equals speed times time.
And time equals distance divided by speed.
It's important to recognize the difference between speed and velocity. When we talk about speed, we're just talking about the distance over time. If you talk about velocity, then you use that same speed, distance over time, but in a given direction. So in this example, we're just adding east to the car's movement to make it velocity. Now let's move on to acceleration. The formula for acceleration is change in velocity over time. In the blank there, you're going to want to draw a triangle. The triangle is called a delta, and in science that means you're calculating the change in that unit. To calculate the change in velocity, you take the final velocity and subtract the initial velocity to find the difference. Let's look at an example. If a car is moving 10 meters per second and speeds up to 20 meters per second over 2 seconds, what is the car's acceleration? So I take my final velocity, which is 20 meters per second. I subtract the 10 meters per second, which was my initial velocity, to get the change of 10 meters per second. I divide that by the amount of time it took the car to make that change, which is 2 seconds, for an acceleration of 5 meters per second squared. Because an acceleration just measures the change of velocity, the speed with direction, it can be positive or negative. A positive acceleration would mean that the object is speeding up. A negative acceleration would mean that the object is slowing down. Some other forces that have an effect on matter is mass, which is just the amount of matter in an object measured in grams. Weight is the amount of matter in an object, but it's combined with the force of gravity, and that's measured in newtons. Newton also had a law about gravity. The Law of Universal Gravitation states that all bodies exert a gravitational attraction on all other bodies. Gravity depends on mass. The larger the mass, the more gravity. Gravity depends on the amount of distance between 2 objects. The further away from Earth you are, the less you weigh. In this image, we're just taking a look at those 2 ideas again. The force of gravity between 2 objects increases as mass increases. The force of gravity decreases as the distance increases.